Hello everyone. This is Dr. R.Sasikumar, Professor, Department of Computer Science and Engineering from RMDEC Engineering College. Today I am going to take about how to fetch the instruction and what are the steps required to execute that instruction. This is the overall diagram for executing one instruction. So there are two tasks to perform the execution of one instruction. First one, how to fetch the instruction from memory. And after fetching the instruction, what will happen that the next address, how the next address will be generated. So the first diagram here, the instruction fetch section, the first and foremost thing is what program counter, because the program counter which is supply the address to memory address register. So once the address is available in that memory address register, then the MIR is ready to fetch the instruction from the memory. So that is the second step. Then after fetching the instruction from the memory, that instruction will be transferred to AR. Uh, uh, so once the instruction is moved on to IR, IR is nothing but what instruction register. So once the instruction is moved on to IR, then what is the role of that IR means what the IR instruction register? It is going to analyze and decode the register. So what is the meaning means what? So far the system doesn't know what type of instruction is currently available. So after executing that instruction register, then it will give the detailed instruction about information about that instruction, what type of instruction is currently available, and how many operands are available. So the after performing the decoding operations, then with the help of MDR, that is a memory data register, that the corresponding data can be fetched from the memory. So here that data can be stored into what general purpose register, that is called what a register file. Here we have used that RA and RY. Then after fetching the data from that instruction register, then the ALU can be perform the necessary operation. So this is what instruction fetch section. So I repeat once again, the first and foremost instruction start with the program counter. The program counter is nothing but what it always points the address of the either first instruction or address of the next instruction. So this is what instruction address generated. Uh, this is what instruction address generated. So what is the meaning of that instruction address generated means? But once the instruction is move on to a program counter, then that address will be incremented automatically. So this is what the instruction which is supplied to MIR. The MIR pass that memory address to memory, and if the address is matched with that memory, then the corresponding instruction will be fetched from that memory. Once the instruction is fetched from the memory, then that will be transferred to IR. IR is nothing but what instruction register. It is the purpose of the role of IR is what to decode the instruction and analyze the instruction, how many operands available and what type of instruction is available. So once the decoding operation is completed, then with the help of control signal, the data can be read from that memory, and that will be transferred to memory data register. Okay. Then the ALU will perform the necessary operation. This is what instruction fetcher. And the second one is what instruction address generator. So when the address will be incremented means what whenever the instruction is move on to IR, then the program counter will be incremented by 4 automatically. So that's why this is the program counter address. For example, the starting address is 1000. So in that starting address 1000, we have one instruction. For example, add instruction means what that instruction is move on to IR. So once the instruction is move on to IR, then automatically the program counter will be incremented by 4. So 1004. So the 1004 again that will be pointed to what that will be sent to that multiplexer PC1. If it is 1 means what the program counter points the address of the next instruction. Okay, this is the way to generate the address. Okay, if it is suppose if it is a branch instruction means what here the program counter address will be incremented by 4. Suppose if the branch instruction is taken branch, then uh, we have to update the target address. So that is a if a multiplexer increment equal to 0 means what the program counter will be incremented by 4 automatically. If it is a target address and if the branch is a taken branch means what, then the target address will be updated. So this is the way to generate the address generator. Okay. And what are the steps required to fetch and execute the instruction add R3, R4, R5? So add instruction is belongs to R format instruction. R format instruction which contains what three data, two source register and one destination register. So R3 is a destination register and R4, R5 is called what source register. So first we have to fetch the instruction. So where the instruction is available means what every instruction must be available in that particular memory address. So the how to fetch the address means what initially the program counter points the address of the starting instruction or address of the next instruction. So the program counter address will be supplied to memory address. What is called memory address means what here we have a two one special register that is called what memory address register. It is going to read the instruction from memory. So once the address is moved on to memory address, then the control signal issues one signal called what read memory, because to perform the memory operation, the memory can be read by the memory address register. So after fetching the instruction, the data is called what not input, but the instruction is move on to IR. So the system doesn't know what type of instruction is currently available. But the IR is what is the role of IR means what it is going to analyze and decoding the instruction. Once the instruction is moved on to IR, then the program counter will be incremented by 4 automatically. So this is the this first step is compulsory or mandatory for all the instructions. So this is the diagram. So once the instruction is move on to IR, then the program counter will be incremented by 4 automatically. Then second step, after decoding that instruction with the help of MDR, memory data register, can get the data from the memory. So what is called R4? R4 is nothing but what a source one. R5 is nothing but what source register two. So we have a two register RA and RB. So we can show that R4 source register one will be stored into RA and source register two will be stored into RB. Okay, then what is the operation means what decoding instruction, which is it will inform that to the control signal for add instruction. Now the control unit generate the control signals. After generating the control signals, the ALU can perform the addition operation. So the content of RA will be added with the content of RB. What is the content of RA? That is a value of R4 register, and content of RB is nothing but what the content of R5. So these two registers will be added and the result will be stored into RZ temporarily. Again, that content of RZ will be transferred to RY. This is also temporarily. Finally, what the content of RY will be transferred to R3. So the R3 is called what a destination register. So this is the way to execute the add instruction. Add instruction belongs to what R format. Actually, all the R format instruction which contains only 4 steps. Out of 5 steps, step one is mandatory, step two mandatory, step three also mandatory, and step four not required for all format instruction, and step five is mandatory. So that's why the content of RZ is temporarily stored into RY. Again, the content of RY is transferred to R3, that is a destination register. So all the R format instruction, step four is not required. So totally 5 clock cycle is required to execute one instruction. So for all the R format instruction, add, subtraction, multiplication, division, all type of logical instruction, the step four is not required. So maximum 4 steps are required to execute that one instruction. And the another example, how to execute the branch instruction. Okay, so the branch instruction means what? Again, the first step is the mandatory for all the instruction. The program counter which is apply the address to memory address. Then once the address is moved on to memory address, then it's going to perform the read operation. So after performing the read operation, the corresponding data, the data is nothing but what instruction will be transferred to IR. Once the instruction is moved on to IR, then the program counter will be incremented by 4. Now the program counter points the address of the next instruction. So the role of IR is nothing but what? To analyze and decode the instruction. After analyze and decode the instruction, this is the instruction branch if R5 equal to R6, then loop. If the content of R5 is equal to content of R6, then the control is transferred to loop statement. Otherwise, the control will be transferred to the next statement. So the content of R5 will be transferred to RA. and the content of R6 will be transferred to RB. So now both RE and RB, which contain what the value of RP and R6. Now in third step, we have to compare both RE and RB equal or not. If RE equal to RB, then the PC will be program counter address will be the target address. So what is the target address means what? Loop address. Loop address is nothing but what a target address. So how to compare that RE and RB is equal means what? Here the ALU which perform the subtraction operation, because RA minus RB both are equal, then the result will be 0. If it is 0 means what? Then the control will be transferred to loop address. What is it called loop address? Loop address is nothing but what? Branch offset address. So what is a program counter means what? Suppose if the instruction belongs to what 1000 means, then here the program counter points what 1004. Okay, so the target address is what loop address. Loop address is what 2000 means what. So how to reach that 2000 means what? Once the condition is satisfied, if RA equal to RB, then the program counter, content of program counter plus branch offset. What is the content of program counter? According to this example, 1004. What is the branch offset? 996. So 996, then 1004, you will get 2000. So once the control condition is satisfied, then the program counter must be updated the project the branch target address. So and step 4 is not required and step 5 also not required. So this is the steps required to execute the branch instruction. I hope you understand how to execute add instruction and how to execute the branch instruction. Okay, thank you.